Bismillahirrahmanirrahim. Let's start with the quote of the day. Once you replace negative thoughts with the positive ones, you will start having positive results. Assalamu alaikum, everyone. The topic I'll be presenting today is the surveillance of drinking water. I'll be giving this presentation under the kind supervision of my most respectable, most honorable supervisor, Professor Dr. Saira Afzal. The learning outlines of today are Introduction, National Drinking Water Policy, WHO Guidelines for Drinking Water Quality, Surveillance of Drinking Water Quality, Recent Advances, and MCQs. The learning outcomes would be at the end of the presentation, participants would be able to describe the guidelines and the surveillance of the drinking water quality. So water has two types of issues, quality and quantity. So the quality is basically, we can assess the water pollution, and the quantity is the water scarcity. In Pakistan, 50% of diseases and 40% of the deaths occur due to poor drinking water quality. Diarrhea, a waterborne disease, is reported one of the leading cause of death in children. According to the SDGs Target 6.1, by 2030, achieve universal and equitable access to safe and affordable drinking water for all. Indicator, proportion of population using safely managed drinking water services. National Drinking Water Policy, in line with National Environmental Policy and VN 2030 objectives, are one of the objective is provide access to safe and sustainable drinking water supply to the entire population of Pakistan by 2025. So the guidelines for the drinking water quality, the WHO published guideline for drinking water quality, its implementation ensures safety of drinking water supplies. Guidelines for drinking water quality recommended by WHO 2011 relate to acceptability aspects, microbiological aspects, chemical aspects, and the radiological aspects. For the acceptability aspects, we have to check the physical parameters and the inorganic constituents. Physical parameters, turbidity. Drinking water should be free from turbidity, interferes with disinfection and microbiological determination. Acceptable level, turbidity of less than 4, and measured with turbidity meter. You can see in the picture how it looks when it's from low turbidity and when it goes to the high turbidity. For the color, drinking water should be free from color, organic matter, iron, magnesium, industrial waste, etc. The guideline value is 15 true color units. For the taste and odor, developed due to contamination by chemicals, storage and distribution, indicative of pollution or malfunction during water treatment or distribution. Temperature, low water temperature decreases the efficiency of treatment process, and the high water temperature enhances the taste, odor. Korean problem may increase. No guideline value is recommended. Inorganic constituents, chlorides. All water include rainwater chloride. Standard level for chloride is 200 milligram per liter. Maximum permissible level is 600 milligram per liter, measured by the spectrophotometer on titration or the titration method. The spectrophotometer you can see in the picture. Hardness. Taste threshold for calcium ion is 100 to 300 milligram per liter. Excessive soap consumption and scum formation forms deposits of calcium carbonate scale on heating. Soft water, low buffer capacity, corrosive for water pipes, made by titration method. Ammonia. Ammonia originates from metabolic, agricultural, and industrial processes and from the disinfection with chloramine. Natural levels below 0.2 milligram per liter. Anaerobic groundwater contains 3 milligram per liter. Its presence indicates pollution by bacteria, sewage, or animal waste. pH. pH less than 7 causes severe corrosion. Acceptable range is 6.5 to 8.5, measured with the pH meter. Hydrogen sulfide. Acceptable limits are 0.05 to 0.1 milligram per liter. Gives rotten egg odor, stagnant water. Iron. On exposure to atmosphere, ferrous iron oxides to ferric iron gives a reddish brown color to water, deposits slimy coating on the pipes. Sodium. Measured with the flame photometer, average taste threshold for sodium is 200 milligram per liter. You can see in the pictures how does the flame photometer looks like. Total dissolved solids, important effect on the taste of the water. Acceptability levels of the taste dissolved solids is less than 1000 milligram per liter. Excessive levels cause scaling of boilers and pipes. Zinc, gives undesirable taste, and zinc content is more than 5 milligram per liter. Opalescent look and greasy film on boiling. Manganese. For the manganese, acceptable levels is less than 0.1 milligram per liter, and excessive manganese stains sanitary wear and laundry. Copper. Increases corrosion of steel fittings. Concentration is more than 1 milligram per liter, causing the staining of laundry and the sanitary wear. Aluminium, the concentration is more than 0.2 milligram per liter, leads to deposits aluminium hydroxide. The microbiological aspects. The microbiological indicators, virological aspect, and the biological aspects. Bacteriological aspects, we have to look for the coliform organisms which are present in the human intestine. Presence indicates the fecal contamination. Fecal streptococci occurs in feces, conformity evidence of the recent fecal contamination. And the Clostridium perfringens resist chlorination, presence suggests fecal contamination. Coliforms have two groups, the fecal and the non-fecal one. The fecal contains the E. coli and the non-fecal contains the Klebsiella aerogens. Why coliforms? Coliforms are abundant in intestine, 200 to 400 billion per day, easily detected by culture, survive longer than the other pathogens, and greater resistance to forces of natural purification. Bacteriological quality of drinking water, the organisms and the guideline value. All water intended for drinking must not be detectable in any 100 ml sample. Treated water entering distribution system, E. coli total coliform count, must not be detected in any 100 ml sample. Treated water entering distribution system, E. coli total coliform count, must not be detectable in any 100 ml sample. In case of the large supplies, must not be present in 95% of samples taken throughout any 12-month period. Now, the virological aspects, free from virus, disinfect with 0.5 milligram per ml of free chlorine residual after contact period of at least 30 minutes at pH 8. Others need 0.2 milligram per milliliter. Criteria. Ozone 0.2 to 0.4 milligram per milliliter for 4 minutes. The biological aspects, the protozoa are the E. histolytica. The helminths are the infective form of round form, hookworm, and the schistosomes. Free-living fungi, algae interfere with the water treatment. Chemical aspects, we have to look for the inorganic constituents and the organic constituents. Inorganic constituents are arsenic, cadmium, chromium, fluoride, lead, mercury, nitrate, nitrogen, selenium. And you can see the guideline value that is recommended for them. It's present in front of them. For the fluoride, it's 1.5 milligram per liter, and so on. Fluorosis. Excess fluoride in the body above 1.5 to 2 ppm would lead to the fluorosis. There is dental fluorosis and as well as the skeletal fluorosis. The organic constituents include the chlorinated ethenes and the chlorinated alkanes, the aromatic hydrocarbons, benzene, and so on. pH guidelines, pH and turbidity restriction on coal tar-based lining in storage tanks, sources of contamination should be identified. The main source of pH, the polynuclear aromatic hydrocarbons contamination in drinking water is usually the coal tar coating of drinking water distribution pipes used to protect the pipes for corrosion. These are also formed during some methods of food preparation such as charcoal boiling, grilling, roasting, frying, or baking. Radiological aspects should be as low as possible. The guidelines values for these are gross alpha activity of more than 0.5 becquerel per liter and the gross beta activity of 1.0 becquerel per liter. 1 becquerel is equal to 1 disintegration per second. Surveillance of drinking water quality now. A water quality surveillance and response system, SRS, is a framework designed to support monitoring and management of distribution system water quality. The system is comprised of one or more components that enhance a drinking water utilities capability to quick detect and respond to water quality issues. Continuous and vigilant public health assessment and overview of the safety and acceptability of drinking water supplies according to WHO 1976. The service indicators include quality, quantity, accessibility, affordability, and continuity of drinking water supplies. Objectives of surveillance: identify and evaluate factors associated with drinking water which could pose a health risk, to take both preventive and remedial action for development of rational strategies for improvement of quality of water supply services to meet accurate national standards and the institutional targets. The surveillance approach is the audit approach and the direct assessment. In the audit approach, information regarding system performance is given and review the records to ensure data is reliable. Activities in surveillance function. Approval of new sources, including the private-owned water shed protection, approval construction, and operating procedures of water works, disinfection of the plant and distribution system, periodic flushing programs and cleaning of water storage facilities, certification of the operators, regulation of chemical substances, and the cross-connection control, backflow prevention, leak detection control. Sanitary surveys, monitoring programs, development of codes of practice for well construction, pump installation and plumbing, inspection, quality control in the bottled water. Elements of surveillance program: the sanitary survey, sampling, bacteriological surveillance, presumptive coliform test, multiple tube method, membrane filtration technique. Number 2 is the detection of fecal streptococci and the Clostridium perfringens. And third is the colony count. Then we have the biological examination and the chemical surveillance. Number 1 is the sanitary survey. A sanitary survey defined as an on-site inspection and evaluation by a qualified person of all the conditions, devices, and practices in the water supply system which pose a danger to the health and well-being of the water consumer. A new source is being contaminated. Laboratory analysis indicates hazard to health and outbreak occurs to interpret bacteriological, chemical, and physical analysis of samples. Whenever there is any change takes place that can affect the water system, for example, in industries coming up in the watershed. Number 2 is the sampling. Ensure no external contamination. Asepsis glass bottles with security fitting stoppers or caps with no non-toxic liners. Sample for general analysis is equal to 2 liters and metrological analysis is equal to 250 ml sterilized bottle. Meta-analysis is equal to 1000 ml acidified sample. The general guidelines for the sampling are rinse sample container 3 times with the sample before it is filled. Leave small air space in the bottle. Allow mixing of sample at the time of analysis. Label the sample code and the sampling date should be clearly marked on the sample container or the tag. Complete the sample identification form for each sample. The sample identification form should be filled for each sampling. Sample identification forms should be kept in master file at the lab where the sample is analyzed. The Winchester quad bottles for physical and chemical examination. They are shown here. Sampling is done by sampling assistant. Number 2, the basic type of sources for sampling. The water from a tap in a distribution system, and the water from a tap in distribution system, and water from watercourse, the river, lake, well, etc. So now the sampling techniques: sampling from well, sampling from reservoir, transport and the storage of sample, date, time of collection, dispatch, source, rainfall, and the findings that you have to check for. The bacteriological surveillance. Complete bacteriological examination consists of 3 tests: presumptive coliform test, the detection of the fecal streptococci and the Clostridium perfringens, and third is the colony count. A, the presumptive coliform test. It consists of the multiple tube method, the conformity test, and the membrane filtration technique. For the conform test, take the positive tube for the presumptive test, incubate on plate at 37 degrees centigrade for 24 hours and at 44.5 degrees centigrade for 24 hours. Look for typical colonies in the media: blue, black with green metallic sheen. Colonies are of the E. coli. The membrane filtration, in the membrane filtration technique, bacteria are captured by the filters and then water passes through the filter. So we use lactose, tegretol, agar, and the membrane lauryl sulfate lactose. Colony count: nutrient agar at 37 degrees centigrade and 22 degrees centigrade. An estimate of general bacteria purity of water, same source at frequent intervals, may be of considerable value. A sudden increase in the colony count may give the earliest indication of contamination. Water at the point of consumption and the plate count after 2 days at 37 degrees centigrade, and then the plate count after the 3 days at the 22 degrees centigrade. So in the case of disinfected one, the plate count after 2 days would be 0, and the plate count after 3 would be 20. And in the case of the non-disinfected, it would be 10, and in the other case, it would be 100. Number 4 is the biological examination. Water may contain microscopic organisms such as algae, fungi, the yeasts, protozoa, rotifers, the minute worms, etc. These organisms are collectively called plankton. They produce odor and objectionable taste in water. They are index of pollution. The degree of pollution is assessed qualitatively and quantitatively by the number of organisms prevailing in water. Number 5 is the chemical surveillance. Chemical surveillance of drinking water is assuming greater importance in view of industrial and agricultural pollutants into raw water sources. Tests for pH, color, turbidity, chlorides, ammonia, chloride demand, and residual chlorine are basic tests. Complete chemical analysis include analysis for toxic metals, pesticides, organic chemicals, and radioactivity. Now it's the time for the recent updates. An estimated 70% of households still drink bacterially contaminated water. Pakistan has made significant progress in improving access to sanitation, yet 25 million people still practice open defecation. Lack of access to proper sanitation facilities impacts negatively the health and the well-being of children. 53,000 Pakistani children under 5 die annually from diarrhea due to the poor water and sanitation. So in this article, we'll assess the drinking water quality, status, and contamination in Pakistan. According to the abstract, due to the alarming increase in population and rapid industrialization, drinking water quality is being deteriorated day by day in Pakistan. So about 20% of the whole population of Pakistan has access to safe drinking water. The remaining 80% of the population is forced to use unsafe drinking water due to the scarcity of safe and healthy drinking water sources. The primary source of contamination is the sewage, which is fecal, which is extensively discharged into the drinking water system supplies. Secondary source of pollution is the disposal of toxic chemicals from industrial effluents, pesticides, and fertilizers from agriculture sources into the water bodies. Anthropogenic activities cause waterborne diseases that cause about 80% of all the diseases and are responsible for 33% of deaths. This review highlights the drinking water quality, contamination sources, sanitation situation, and effects of unsafe drinking water on humans. There is no immediate need to take protective measures. There is immediate need to take protective measures and treatment technologies to overcome an unhygienic condition of drinking water supplies in different areas of Pakistan. Safe drinking water point UNICEF constructed by the UNICEF in Agrabad, Quetta district, Balochistan province, Pakistan. Pakistan Country Program Strategy from 2016 to 2021. So Water Aid in Pakistan, WAP, carries forward its global organizational mission of ensuring universal access to safe water, sanitation, and hygiene, WASH, which since 2014 has been to reach everyone, everywhere by 2030. Now, the Pakistan Water Week 2021. December 6th to 9th, 2021. Pakistan Water Week 2021 needs for sustainable water management in a climate crisis for Indus Basin, December 6th to 19th, 2021. So according to this, while identifying problems, however, Pakistani Water Week 2021 will also focus on climate resilient solutions, both digital innovations along with those based on the nature. In addition, the role of the media and of the women's leadership will also be explored in the content of water. Ultimately, the goal of the Pakistan's Water Week 2021 is to figure out strategies to meet the competing water needs of different sectors, design a research plan that will guide investments in applied research and development, identify sustainable water management strategies to take climate change into account, and identify gaps in policies and practice that can be filled with the better scientific understanding. But in addition to high-level policy discussion, Pakistan Water Week 2021 will also incorporate a public awareness campaign, which includes the use of social media exhibitions, highlighting the coordination between the private water sector with the academic and the public sectors, a poster competition for university students, and the use of the games and debate competitions to raise awareness among the youngster students. Water quality assessment and management. Access to safe drinking water is the basic human right. Pakistan VN 2025 and the Sustainable Developmental Goals 2030 impose obligations on Pakistan towards achieving its water and sanitation goals. Drinking water is also placed on priority number 1 in the approved National Water Policy 2018. One of the major components of water quality is the monitoring of quality of water for multiple purposes in relation to human and environmental health, such as drinking, irrigation, ecological aspects, etc. Now, according to the CDC, the Drinking Water Week, drinking water refers to the water that comes out of our tap or bottled water. Every day, people rely on the safe drinking water in many different ways, such as for the hand washing, bathing, cooking, washing clothes, and drinking, etc. So, the Drinking Water Week is May 2 to May 8, 2021. The multiple choice questions now. Number one is in a village ABC, people used to bring water from canal near the industrial area for the daily use. If domestic water has a color and a specific taste, it can be classified as A, contaminated water, B, clean water, C, polluted water, D, wholesome water, and E, potable water. Anyone? It's C, polluted water. Number two, research team in an awareness program regarding clean drinking water shared the information that source of water which can be ingested without any prior treatment of purification is A, rainwater, B, wells, C, surface water, D, groundwater, E, rivers. Anyone? D, groundwater. Third, a researcher with his team has visited the area with an epidemic of gastroenteritis. A sample of drinking water was taken and sent to for the examination. The organism responsible for water pollution and this epidemic would be A, Vibrio cholera, E, E. coli, B, E. coli, C, Salmonella, D, rotavirus, and E. Shigella. It's B, E. coli. Fourth, a researcher has visited the area and took the samples of water from different sources of water to check the presence of fecal coliform bacteria. The fecal coliform count would be maximum in A, sludge, B, sewage, C, contaminated water, D, inadequately treated water, and the E, clean water. Anyone? It's B, sewage. Fifth, a researcher has visited the area ABC and collected the water sample for bacteriological examination of water and it to the lab. The amount of sample required for examination is A, 250 ml, B, 350, C, 450, D, 550, or E, 500. It's A. Sixth, a researcher has visited village ABC and observed that the mostly youngsters of the community, especially children, had staining and pitting of teeth. This condition is observed by the ingestion of water, which has high content of A, aluminium, B, zinc, C, fluoride, D, mercury, E, iron. Anyone? The answer is C. Seventh, a researcher has visited the area and collected the water sample to check the quality of water. Regarding transportation water sample to the lab, most important information to be accompanied is A, geological information of the soil, B, any suspected source of pollution, C, date, place, and time of dispatching the sample, D, source of water, or E, impurities level. It's C. Eighth, a researcher has visited the area and collected the sample of water as there is suspicion for the fecal contamination. Confirmation test for detection of fecal E. coli in water sample is A, multi-tube test, B, incubation at 44 degrees Celsius, C, colony count, D, plate count, or E, none. The answer is B. Ninth, in Karachi, one of the beaches is allocated for various sports, water sports including surfing, water skiing, and swimming. Most important health risk associated with recreational use of water is A, drowning, B, contamination with sewerage, C, exposure to the heat and ultraviolet rays, D, chemical pollution, or E, none. The answer is B. Number 10, a researcher has visited the area and observed that many people, men and women of that community of the area, have swelling in front of the neck. This commonly seen non-infectious disease associated with water supplies in Pakistan is A, diarrhea, B, methemoglobinemia, C, dental fluorosis, D, goiter, or E, anemia. It's D, goiter. Now here's the key of the MCQs. References. Thank you so much, everyone. The link is also mentioned here. Please like and subscribe. You can check all the videos there.